Hello everyone, welcome to the course on chemistry. In previous lecture, we have seen what is the meaning of electronic configuration, atomic number, atomic mass number, then the subshells. There are 4 subshells S, P, D and F. All those things we come to know, and I am explaining how to write the electronic configuration for an element. So we have written the electronic configuration up to carbon. Now we will move to the next element, that is nitrogen. So in nitrogen, the atomic number of nitrogen is 7. So if the atomic number is 7, how to write its electronic configuration? So here again, if we observe the first shell, in the first shell, in S subshell, 2 electrons will be present. So after that, the electrons will go to the second shell. Here totally 7 electrons are there. So therefore, we have to fill all the 7 electrons in the nitrogen. So next, they will go to second shell. First, they will fill up in S subshell. Again 2 electron got filled. And in the same shell only, that is in second shell only, another subshell is there, that is P. And in that P subshell, they will fill the remaining electrons. So 4 electrons are already filled. How many electrons are remaining? 3 electrons. They got filled in P subshell. So this is the electronic configuration of nitrogen: 1s2, 2s2, 2p3. In S subshell, the maximum capacity will be 2, and in P we can fill the electron up to 6. So here now the 3 electrons got filled. Next we will see the oxygen. The atomic number of oxygen is 8. So its electronic configuration becomes, the atomic number 8 means the number of electrons in oxygen will be 8. So therefore, in first shell, S subshell, 2 electrons got filled. Again, in second shell, 2 electrons will get filled. And in P subshell, the remaining electrons gets filled. That is how much? 4. 2, 2, 4. Totally 8 electrons. So this is the electronic configuration of oxygen. Then we will see the fluorine. The atomic number of fluorine is 9. So therefore, the number of electrons will be 9, and hence its electronic configuration becomes 1s2, 2s2, 2p5. And then we will see the neon. The atomic number of neon is 10, and thus the electronic configuration will be 1s2, 2s2, 2p6. So this is the electronic configuration of neon. Then next, atomic number 11, that is sodium. So sodium, its atomic number is 11, and thus its electronic configuration will be 1s2, 2s2, 2p. Now there are totally 7 electrons are remaining. Now only 4 electrons are filled. There will be presence of still 7 electrons in the sodium. And now here we can't write this 7, 2p7. We can write only 6, because maximum number of electrons in P subshell will be 6. So now another electron is remaining. Where does that remaining electron will goes? it will goes to the third shell, because in the second shell the maximum number of electrons will be 8, and those 8 electrons are filled in the second shell, that is 2 electrons in S subshell and 6 electrons in P subshell. So totally 8 electrons are filled in second shell. Now after filling, the remaining electrons will go to the third shell. So here 1 electron is remaining, so it will goes to third shell. And in third shell, which one will comes first? S subshell will comes first again, and thus we will fill the remaining 1 electron in S subshell. So this is the electronic configuration of sodium. Then similarly, we will see the magnesium. Magnesium atomic number is 12, and thus the electronic configuration will be 1s2, 2s2, 2p6 and 3s1. So this is the electronic configuration of magnesium. Sorry, it is 3s2 because the 12 electrons are present. Then next we will see the atomic number 13, that is aluminium. So aluminium, it has the atomic number 13. Now what would be its electronic configuration? 13 electrons are there that you have to fill up. So 1s2, 2s2, 2p6, 3s. Will you write 3 here? No, because maximum capacity of S subshell is 2. So we have to write 3s2. Now again 1 electron is remaining. Where it goes? Will it go to fourth shell? No, it will remain in third shell only. There will be presence of another subshell, that is P. There it will get fills up. So P1, 1s2, 2s2, 2p6, 3s2, 3p1 is the electronic configuration of aluminium. And if we observe the next, that is silicon, its atomic number is 14. So again 14 electrons are there. So therefore we can write its electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p2. Now the electrons will go on fills up in P subshell up to 6. So therefore this will remain same, and only change will be in last P subshell. Okay, so if I take the phosphorus, atomic number is 15. There again the electronic configuration is same. At the end we have to write 3p3. And next, after phosphorus, sulfur, its atomic number is 16. There we will write 1s2, 2s2, 2p6, 3s2, 3p4. Again chlorine, its atomic number is 17. So at last we will write 3p5. And after chlorine we will have argon, that is atomic number 18, and its electronic configuration becomes 3p6. Now after argon, which element will comes? Potassium, its atomic number is 19. So therefore the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. Next, where does the another electron will goes? It will fills up in 4s1. Here we will write 3p6, 4s1. Here in third shell, another orbital is there, that is 3d. But in that 3d we will not fill up first. First the electron will jumps to fourth shell, and then only it will comes to 3d. You have studied the Aufbau principle. According to Aufbau principle, we have to fill the electron. So what it tells? The electrons are filled in the increasing energy levels. So here 1s2, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. In this manner, we have to write the above principle. So first electron will fills up in first 1s, then 2s, then 2p, 3s, then 3p. After 3p, where it goes? 4s. After 4s, we will fill up in 4d, 4p and 5s. So you have to remember this. So based on this, we can fill up the electrons and we can write the electronic configuration. Then if we observe calcium, its atomic number is 20. So what would be its electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6 and then 4s2. So after this, the next one, that is scandium, its atomic number is 21. There we will write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now the electron will fill up in 3d, because after 4s, which one will comes first? 3d, then 4p, then 5s. Here we will write 3d1. So again, next vanadium, okay, titanium. There the D in D subshell, the electrons will go on fills up to 10. 1 to 10. This will remain same. That is 21 to 30. The electronic configuration up to this, it will remain same. The only change that you will observe is in electrons present in D subshell. That will vary from 1 to 10. At atomic number 30, the electronic configuration will becomes, the zinc will have atomic number 30. There the electronic configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay. So then if we move to the atomic number 31, then after D, where it will goes to 4p. Then you have to write 4p. Okay. So based on above principle, we will go on filling up the electrons in the shells as well as subshells. Okay. So remember this electronic configuration. At least you know how to fill the electrons and what is the electronic configuration from the elements 1 to 30. 1 to 30 elements, you should know their atomic number and their electronic configuration. So this is very useful up to second PUC. Okay, and also in competitive exams like KCET, NEET and JEE. So this is very helpful. So remember the electronic configuration of 1 to 30 elements with their atomic number. So here is the list of the elements and their symbols as well as their electronic configuration. So here I have mentioned only 1 to 20 elements. Okay, but you have to perfect up to 30 elements and their electronic configuration.